Okay, next up, we are looking to find the Lewis structure for what we're given here. And so we have CH3, 3, CNO. And this notation, we've been given it in this order for a specific reason. This is telling us that we have 3 methyl groups attached to our 1 carbon that is going to also be attached to these 2. And so let's start with the 3 methyl groups that we know we have. Yeah, and then this is going to be attached to a nitrogen that will be double bonded to oxygen. Because nitrogen likes to make 3 bonds and oxygen likes to make 2, carbon likes to make the 4, so just filling in intuitively what everything should look like. Next, we can double check our valence electrons just to ensure that everything is accounted for. And so we should have 4 by 4 because of the carbon, plus 9 by 1 because of the hydrogen, plus 5 by 1 because of the nitrogen, plus 6 by 1 because of the oxygen. Let's just label them because this is a bigger compound. And this is what I mean by they gave it to us in this form, because they could have said this and kind of left us a bit more clueless. We would have gotten to the same point, but this just made it a little faster. And so this is going to give us 16 plus 9 plus 11. So you have 26 electrons. Let's see if they're all accounted for. Let's write out what these should actually be because of the H3. So H, 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 because those are bonding pairs that have electrons that we need to account for here. And so in the simple notation, we just write H3 as I did before. But right now, because we're counting valence electrons, it's best to write out everything. So we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. So let me just make sure I have everything. Sorry, these are 36 electrons, not 26 if you do out the math. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36. And so we see all of the 36 electrons are accounted for. And we can double check formal charge on each of the carbons. They have made 4 bonds. We're going to have 4 minus 4 equal to 0. On the nitrogen, it has made 3 bonds and 1 lone pair. So that is going to be 5 minus the 3 bonds minus the 1 lone pair, giving us 0. And then on the oxygen, we will have 6 minus the 4 lone electrons minus the 4 over 2 electrons, so 2, giving us 0, 2. And on each of the hydrogens, they have 1 valence electron and 1 electron in the bonding pair, giving us 0, 2. So our formal charges make sense, our valence electrons make sense, so this is the correct structure. If you'd like to write it out in a way that's more correct, because that is the one that we were counting electrons on and doing all of that, then we may write it like this. Bonded to the nitrogen, double bonded to oxygen. And yeah, that's it for this question.